a question like this, this is where we would start. So we'd start with that 5. 1, 2, 3, 4, 5. Ene stands for a double bond, and it's starting on my second carbon. So here's my second carbon. And so my double bond is right there. And then it's got a 3-methyl. Methyl is a CH3, and it's on the third carbon. So 1, 2, 3, I have a CH3, which means I'm going to have a bunch of hydrogens around the rest of it. Okay, so that's what it initially looks like. So if I'm showing the deduction of this, I would show that my double bond here, ooh, that highlighted funny, sorry. My double bond there is going to get broken. So I would say something like break bond. And then I would show that my 1, 2, 3, 4, 5, that always still has this 3-methyl on it, is going to have a sibling, 3, 4, 5, with a CH3 on it. The difference between these twins is where that OH goes. And on one of them, it can go on the second carbon, and on the other, it can go on the third carbon. So we have OH, OH, and then I can fill in the rest of my hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 of them. Same on this one. And I saw lots of correct answers in the chat. We've got a 1, 2 with my OH there, but each of them have this 3-methyl, so we'll start with there. 3-methyl, 3-methyl, nothing changed with it. We just added or did an addition reaction or a hydrolysis reaction to add the water, H2O, where my OH on 1 is on 2-pentanol versus 3-pentanol. So that would be my deducing part of it. I would show those steps of what they would look like as we go from the double bond to the potential alcohol. What questions do you guys have on that? Okay, I have a question for you all then. I want to know, let's see, we'll look at this one first. So the 3-methyl 2-pentanol, I want to know if this is primary, a primary alcohol, a secondary alcohol, or a tertiary alcohol. So type it into the chat. This first one, 3-methyl 2-pentanol, where there's my OH. Is that primary, secondary, or tertiary? Ooh, and some of you are reading my mind and even saying what I'm going to ask next. Awesome. There was one question just clarifying. So it says the carbon-carbon double bond breaks and forms radicals that the H2O just comes in and takes the place of. That's absolutely correct. Great summary or verification question there. Nice. Okay, we have some different answers here. So if I'm looking at this carbon OH bond. I want to see how many carbons this carbon that's attached to my OH is bonded to. And so it's bonded to this one and this one directly. So that would make this one secondary. Secondary for this one. Okay, and some of you predicted that I was going to now ask about this one, the 3-methyl-3-pentanol. I want to know if this one is a primary, secondary, or tertiary alcohol. So type them on into the chat. Really appreciate we're getting so many people typing in here. Thank you. Okay, good. And some more questions. So I'll get to the question in a second. So we're looking at this carbon that's attached to this OH. And that carbon is directly attached to, let's change the color here, to that carbon, and that carbon. So since it's directly attached to all three of them, that one is tertiary. And then I had a question, how is the first one not tertiary? Because there is that methyl group. Well, the reason is that this carbon is only directly attached to those two carbons. It's not directly attached to the one that's down here. So since it's not directly attached to it, we wouldn't call this one, the first one, tertiary. It would just be secondary because there's just those two carbons there. That's a great question. What other questions do you guys have?
Wait, so is the second one tertiary or secondary?
The second one here, so the 3-methyl-3-pentanol is tertiary.
Okay, got it.
Yep, thank you for clarifying. Awesome, and then a good question tying this into oxidation. So it's just trying to clarify whether a tertiary alcohol could be oxidized or not. And I think that's a great question for the rest of the group. So type into the chat, could a tertiary alcohol be oxidized? Is it likely that it's going to be oxidized? So that means turns into a ketone or an aldehyde. I love the answers. Awesome. No is correct, or no question mark. I like that one. Not easily oxidized, very unlikely, not likely. Yes, all of those answers are perfect. It is not likely. Well done, folks. Awesome. What other questions do you guys have on this? Awesome. So there's another question. So a tertiary alcohol was part of the flow chart. And so the question is it okay that the line of reactions just ends there and it doesn't form anything else? Absolutely, because it's not going to be easily oxidized. We could theoretically do a substitution with it, but that's probably unlikely as well. So yeah, that's totally fine to just end that line there. Great question. Nice. And that was a great question for everybody to hear. That's why I love these questions. Okay. We're going to talk a little bit about the internal assessment, which is that big lab that counts for a good chunk of your IB grade overall. So we're basically done with this first part here. I'm worried that if I touch this, it's going to go forward. So the essential outcome 1, the structure, size, and functional groups of organic molecules determine their physical and chemical properties. We're basically done with that. You're turning in your big assignment for this part of the unit today. So that is awesome. Awesome. So there's a question about switching to 50%. What I was told in an email from Superintendent Osai was that we will not be switching to 50% as we had originally planned. We're going to stick with that 25% capacity until numbers change, either positively or negatively. We might go back into distance at some point if it keeps going the way that it is. But it's going to stay like it was last week, where A1s are there on Mondays, A2s are there on Tuesdays. Nobody's in the building on Wednesdays, but everybody's still signing into connections on Wednesdays. And then Thursdays, it's B1 and Fridays, B2. Whew. And that'll be for as long as it seems necessary. Great question. Thank you for that, Olivia. Okay, so we're moving on to this essential outcome number 2. The IA has to have a single researchable independent variable. And we're going to talk about what that means in some notes today. Just a reminder that the organic reactions flow chart is due by 8 o'clock tonight. It's worth 20 points. It's the same as our first assessment. I'm sure most of you are realizing at this point, I'm not taking off points for work that's coming in late. It just takes a lot longer for me to grade stuff that's coming in late. So this 8 o'clock is more of a way to make sure that you're getting a good night's sleep and not pushing it off until the middle of the night. I hate when teachers give me midnight assignments because I feel like I should keep changing it and making it perfect up until midnight. That's not what I want here. I want to see that you have an understanding of how these different reactions are interconnected, how we can get from one to the next through those planning processes of, let's say I have an alkane, but I want to make a carboxylic acid. How could I do that in the lab? Well, I have to change it first into a haloalkane, and then I can do a substitution reaction with an alcohol, as long as the alcohol is on the end. I want to see that you're thinking through these different things, but it doesn't need to be something that's perfect. Legible, yes, so that I can understand what you're thinking. But really, I just want to see that you're thinking it all goes together. Excellent question. If you have mistakes on it, will you have a chance to fix it? I think it depends on how large the mistake is. So that'll be a kind of case by case thing. I'm guessing you guys are going to be in really good places because you've gone through everything in all of these do nows that we've done in the notes. I have faith that you guys are going to produce good work here. And then do you have to include every reaction? Just make sure that you've got each of the things that are on that checklist, and then that you can show how those different parts are connected, and you'll be fine. Great questions, folks. Awesome. So we're going to have some time to work on that as long as we can get through these notes pretty quick. You'll want to take some notes. I would love to see your faces while you're taking these notes so I know if they're making sense or not. So if you are able to, please unmute your video. Awesome. And here we go. I think, okay, that was right. So in designing your internal assessment, you want to think about something that is narrow in a way because of the requirements that we have for putting stuff together. it would be awesome if we really could do just any type of reaction, like let's synthesize some aspirin. That would be cool, but it's not going to lead us to something that we can meet all of the requirements of what IB is asking for. So in the experiment, really what we're looking for is something that you could plot on a graph, do a line of best fit, see how things are related to each other, but not like forming something out of something else. Okay, so what I've been trying to do when I've been talking with people about what their ideas were, or making notes on your sheet, I've been trying to gear you towards something that would meet that general idea of thinking for things that you could do, get some data, form a plot, and get some results that'll be easy. We don't want something that's gonna like take you a year to do. That's going to be awesome when you're studying to be a chemist and you are synthesizing a new polymer that's going to be recyclable in a way that we haven't been able to have before. That's going to be so cool. You guys are going to be able to go out and do such amazing things, but that's not the scope of the high school chemistry class. Thank goodness. So your independent variable, you can only have one. And I always like to talk about when I was first diagnosed with rheumatoid arthritis and they were trying to figure out what would help to like take care of the inflammation and the exhaustion and all of the other things that go with it. They had to try one thing at a time to know what was having an effect. If I had changed my diet and I had changed my exercise routine and I had gone on 2 new medications and I changed my sleeping habits, if I changed all 5 of those things at the same time, I would not have known which was having a positive effect on my inflammation. And so we had to do this controlled setup even within like dealing with an illness to figure out what's having a positive effect or not. So same thing with your experiment. You want to just change one thing to see if it has an effect on our dependent variable. So our dependent variable is the thing that we're measuring and drawing a conclusion on. So we should pick something that we think will have an effect on the dependent variable. And there could be a whole bunch of different things that affect it. Just like with my rheumatoid arthritis, each of those things are items that people recommend from the Arthritis Foundation to make changes in, to make your illness better. So we just want to think about investigating one thing. And when you get out into the real world, you can go and see, well, if I change this one this way and this one this way, how does that affect it overall? You can get more complex, but at this point, we're just looking for one thing. Your independent variable should be changed 5 times. So thinking back to last year, you all did a design lab of a rate reaction last like April-ish, maybe even May, where you were looking at rates of reactions and you kind of planned out how you would do an experiment with the rate of a reaction. And you said, okay, well, if I want to see how concentration affects the rate of the reaction between these 2 things, I'm going to change that 5 times. And those 5 times give me enough data to get that line of best fit. So I could say I want a concentration of 1 mole per liter, a concentration of 0.5 mole per liter, a concentration of 1/4 mole per liter. I could have a concentration of 2 moles per liter, and I could have a concentration of 0 moles per liter. So just like purified water. So we could have gone through that process, had those 5 iterations, and then I should have seen that as I increased the concentration, I increased the rate of the reaction. So you can have some hypotheses about what would happen. Each of those 5 iterations ideally will have 3 trials. And these iterations and trials are things that people get confused sometimes. So I'm going to go through that example again. So if we're looking at concentration, And let's just make it easier. Let's say a concentration of 1 mole per liter, 2, 3, 4, and 5. Each of those I'm going to do 3 separate times to get an average for. So I would do my concentration of 5 moles per liter 3 separate times, and my concentration of 4 moles per liter 3 separate times. 3 separate times. And then I can do an average of each of them and compare those averages. And by doing it 3 times, I'm increasing the number of data points, which allows me to reduce random errors. And that's an important thing to talk about in your experiment. So I'm going to say it one more time so we can all make sure we've got it written down and think about it when we're writing up our report. We do multiple trials of each iteration. So we do multiple trials of each iteration to make sure that we are reducing random error. By doing multiple trials, we are reducing random error. And then finally, we have to have control variables, because most of the time when we're experimenting, other things could have an effect on my dependent variable. So what I do is I say, okay, that's probably going to have an effect, and I am going to keep it consistent each time. So in my medicine example, if I thought that doing yoga for 20 minutes every day was going to have an effect, but I really wanted to know if the medication was having an effect, and I'd been doing 20 minutes of yoga every day, I would keep that consistent. I would keep doing yoga for 20 minutes every day, and then I would change the medication that I was trying to see which medication worked and which one didn't. What questions do you have before we move on to the next part? Okay. So your research question is really the basis of your whole thing. Like, this is going to be one of the big things that the grader is looking at, and it should guide everything that you do throughout the rest of your report. So you want a really good one, and you can go back and change it if you find that your research isn't really matching up the way that you thought that it would. You can always go back and change it. It's not written in stone, but you want it to be really clear. For instance, I could say, what is the relationship between the concentration of a solution of hydrochloric acid and its initial rate of reaction with magnesium as measured by the volume of hydrogen gas collected over time? Whew. That is actually concise, even though it's really long. It's a mouthful, right? But it tells me exactly what reaction I'm doing. It says what my independent variable is. It tells me what my dependent variable is and how I'm measuring it. So this gives somebody that is out in the real world of chemistry the opportunity to know what your research is about, so they can decide right off the bat, is it something that they're going to spend their time reading or not? And if you don't quite have everything written down, that's totally okay, because these are posted and you're welcome to look back at them anytime. And the video will be posted as well. One thing that we have to be careful of is it has to be tied back to a chemistry topic. We're in our chemistry class, we're doing our chemistry IA. We know that biology and physics and environmental science, like, they all overlap with chemistry. Chemistry is kind of the central science. So all of those things overlap, but what we're looking at in our experiment has to tie back to the chemistry that we've done. So yeah, it can be an environmental chemistry experiment or it could be a biochemical experiment, but we have to focus on the chemistry aspects of it when we're talking about what's going on. So a good place to start would be looking at the chemistry guide, that big packet that has all of the different standards that you need to know for chemistry. That is a really good place to start, or to go back to make sure that you're staying on the chemistry path and not veering too much into biology or physics or environmental science. Thank you. Background information is a requirement, so be prepared to quote and paraphrase and summarize. And so that means that you are going to have a formal works cited. I don't care whether you're using APA, MLA, whatever, you just have to be consistent about how you're citing. That's the main thing, just to be consistent.
Wait, so we're gonna have to do like a write-up or like something of the sort?
Yeah. And that reminds me, I haven't shown you any previous ones yet. Normally, when we are seeing each other every single day, we'd go through like grading other people's work from the past. I will put them online so you can see what the reports look like. But yes, that's ultimately what we're getting to. So we're finding some clear way of writing a report about what we've done in the experiment. Thank you. I'm sorry, that was definitely not clear.
Yeah, and also I have another question. Like,
Yeah.
when we do the report, can you like help us in any way, or is that something that has to be more like individual?
I will definitely be helping along the way. There's a lot of stuff that I'm not supposed to work with you guys on, or like mark up your report or things like that, but I will be doing as much as I can. So it'll be good. Nice. Great question. Okay. So little bit, we want to avoid plagiarism because your work is actually going to be submitted on Turnitin.com. So it'll be checking for where things might have been not quoted, where it should have been, or that sort of thing. So just keep that in mind as you're going along, as you're collecting information that you want to put in your report. Make sure that you're writing down where you're getting it so that you can refer back to that and make that works cited at the end. And just a little, I was going to say summary, but summarize is one of the words here. Just a reminder about some of the things that my guess is you've learned in English and history already, but a quote is something that's short. You're writing it directly from the source. You're giving credit for it. A paraphrase is looking at a longer section of a book, like a paragraph of a book, and summarizing part of it, or not summarizing, but putting it into your own words. It's generally shorter than the original was. And again, you're giving credit. And summarizing is looking at like a whole body of work and taking those main points from it in your own words, but giving the person that had those ideas the credit. And my guess is you guys will do a bunch of paraphrasing and summarizing in your report. Okay. The internal assessment, they changed the percentages for this year because there's one less examination. So I've got to see what the new percentage is, but it is a good portion of your overall IB grade that you get. There's a section called personal engagement, and that's showing that you're not just taking some canned experiment and doing it word for word as it is. The exploration is the initial part, like where's that background chemistry coming from? Where, what are you planning for your experiment? So that's kind of the planning part of it. The analysis is where you've collected data and you start looking at it, maybe putting it into graphs, that sort of thing. The evaluation is really looking at the results that you got and saying, what does that tell me about the exploration? And then communication is just making sure that it's clear and concise. Notice in there that it should be about 10 hours of work from start to finish. So that's the planning part, that's the doing the experimenting, that's the summarizing of it. I'm going to give us much more time than that, or many more days than that to be working on this, but that's what IB is expecting we will put into it. And it can be no more than 12 pages. Excellent. I got a question about, can I explain personal engagement more? I'm not going to here, and I'll tell you why in just a minute. That's a great question. And it tells you there, I'll grade it, and then external people are going to take some of your reports and then grade them as well. Because we have a small class, they'll probably take all of you and grade them as well. Just so you know, last year, IB's grades were based off of the IAs. Pretty much all. That's all that they were based on, because we couldn't take the tests. We couldn't get back into school. So if the numbers internationally increase the way that they did last May, that might happen again. So we really want to make sure that our internal assessment is in good shape before they get submitted. And that's why we'll be spending a lot of time on it, just to make sure, just if something goes bad with the virus again, that we've got something good for them to give you a grade on. And again, in here it says the report should be up to 12 pages, and that's including graphs and data and all of that. So I'd say most people's reports are like 10 to 12 pages. But again, that's because it's full of graphs and data. It's not all written stuff. So it's a great question. Okay, here's our timeline. And again, this is written down, or this presentation is available to you. Awesome. Some really good questions are coming in. So planning on actually experimenting is mostly going to be done at home, but during class time. And that should be starting here around the middle of this month, and then finish by December 22nd. But December 22nd is also when I want your first draft of your report. So you're kind of, while you're doing the experimenting, you're also collecting stuff into the format that you would use to do the report. The first assignment that we're doing here, so this planning part 2 and 3, a lot of that can be copied directly and put into your report. So you're really starting to build your report next week already in the planning process that you're doing. Your final report is going to be due on January 19th. So what our days are going to start looking like is a check-in.
Is that a firm due date?
Yes.
Okay.
Firm as in, if we need me to have enough time to grade them before the end of the semester, yes, that's when I need them. But if things are going in a different way, then maybe it'll be a little bit later. We will see. We will see. There's a question about what percentage do you need to pass the IB test? It's based off of the different sections of the exam plus this, and you need ideally you'll get a 4 overall on a grade scale of 1 to 7. So it's not like out of 5 like it is for AP, it's out of 7. You need a 4. And yes, the IA will be part of your IB Chem grade. It's going to be the largest portion of our second quarter grade here. Good questions. So right now, I know this seems overwhelming because it's between now and January 19th. So we've got a lot of time, but I know that tends to overwhelm people. So what we need to worry about right now is just understanding the different requirements a little bit more. So let me escape that. Why did it? Come on, computer. Exit. Okay. And that changed to reach. Sorry, that should say read chapters 6 and 7. So if we go back to our updates here or to the materials, right over on this section, we see that the organic reactions flowchart is due today at 8. We are going to read, I'm going to fix that. I don't know why it changed to reach or why I typed reach, who knows. Chapter 6 and 7, which, oh my goodness, that sounds like a lot. It's just 11 pages and it is a lot of pictures. So this chapter 6 and 7 are really just a lot of pictures. And that goes back to one of the private chat questions, which is, can you explain more about personal engagement? That's where you're going to be reading about it to start with. So let's open this up. So here's that link. Boom, there we go. So you get to skip all of this topic 5 until you get down to, what did I say it was? Page 11 maybe? Oops. No, not H. Not a point. 1, 1. No. 1, 1. Or TT. Isn't this funny? I am just going to go like this. So we need to skip all of these things about junk that we don't need to know about. It's pretty junk, but it's junk for us right now. Here we go. Personal engagement. It's going to tell you what you're looking for personal engagement on just a couple of pages here. And then you're going to get to the exploration, and it'll tell you a little bit about what's expected. So see, it's not a ton of reading, but it'll give you an idea of what is expected. So that's that bit. But also, I wanted to make sure that things were nice and simple to understand. So here, the IA planning document is due on November 13th. So that's a week from today. And it's going to look kind of similar to what you did for the kinetic experiment last year, except with some changes. So this gives you an overview first of what it looks like. And then I've pulled apart all of the main things that you need to know and have for your experiment planning part. So the personal engagement and the exploration basically show up here with these questions. And so ideally, this is going to make your life super easy with planning your IA, because it's going to guide you through the common missteps that people have and past those missteps.